Class, here it is. Trig homework questions. Here it is, 2122. And let's jam with it here. So 21. And I'm going to draw it out like this here. So 2.1 questions. And I'm going to go back and forth between these guys here real quick here. So 17. I have this, and you guys tell me if I'm doing the wrong problem. We're good here. Determine definition, use definition 2 to explain why for any angle theta it is impossible for cosine theta to be a 3. Why is that impossible? Cool, okay, so because, and then I'm going to dot, 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 right? Because cosine theta is, oh, that's a test question, I believe, right? Isn't it? Cosine theta is this right here because cosine is defined to be a over c, right? And a is always going to be less than or equal, less than c, right? You can't even be c, or else we don't have a triangle, right? So therefore, and I don't know, this is kind of extra stuff here. So therefore, cosine theta is going to be less than or equal to 1, right? Therefore, it cannot equal 3 ever. Okay, does that help out there with number 17? Cool, and I'm going to just do this one here. So jump to 47. 2.1, number 47. All right, 47 says this. It's 2 cosine, and then we have an expression here. It's this right here. All right, and this says on the directions here, it says replace x with 30 degrees. X will be 30 degrees for us. So then real quickly here, and if you want to put brackets here, that's fine. Just because whenever we plug stuff in, we always use parentheses right here, right? We're going to make it all official here. Sorry, brackets here, sorry. Like this. Everybody good there? So I got myself 3 times 3 is 90, is that right? That's 90 minus 45. And then I don't mind if you guys not put the what is it called? The degree symbol, right? As you're doing the work, because some people do that. They don't put the degree symbol. But at the end, if it has a degree at the end, you should put the answer though. So 90 minus 45 is 45 degrees. And anybody, what's cosine of 45 degrees? Root 2. And now I have a 2 over root 2. That's fine. Or, and this is a perfect answer, no problem. If you did want to rationalize your denominator, you would have went like this. Is that right? 2 root 2 over 2, and the 2's are gone. So then you're just left with that right there. So that is true. So hold on. Is this true? 2 over root 2 is the same thing as root 2? Absolutely. Either answer is just fine because we do not need to rationalize answers. Question? That's fine. I mean, as long as it makes sense to you and I look at the homework, I like, okay, that makes sense, right? I mean, part of it is truly here, honesty thing is, do you know what you're doing, right? If you know what you're doing, that's cool, you know. If you want to put in maybe like what you plugged in, at least that right here, and then if you want to go to here, if you're gonna, that's fine, you know. You can do that, or here, then here, and then here, right? Good question though. Okay, are we good with 47? 49, I believe. Is this find the exact value of the following? Give me cosine of 30 degrees. Or is it secant of 30 degrees? It's secant of 30 degrees. All right. How do we do that? Anybody? Yeah, we can do one over cosine. Right, there's our relationship, right, between secant and cosine. And cosine of 30 degrees is 3 over 2. 3 over 2, perfect. So then if I plug it in here, I'm going to have this. And whenever you have a top of a 1, It just means reciprocals, right? Just flip it over and you're done. Yeah, if you could do it in your, like I said, if you could do it in your head, that's fine. I trust you. If you're doing everything in your head and you get a 60 on the test, then we have a conversation. All right, 61, 63. 61. Suppose that an edge, oh yeah, this is the fun one, is that right? This is this guy, and then this guy, and then we can combine these guys together. Right there. Okay, and I got myself a C, D. What's at the end of a G at the end? Yeah, G here. And A, and E, and F, H, and B. Okay. So how do they do this? So A, B, C, D, E, F, E, F, G, B. Okay, they did a zigzag pattern, right? A, B, C, D, E, F, G, H. Okay. Suppose that each edge of the cube in the figure is 5 inches long. Each side is 5 inches each edge. Find the sine and cosine of the angle formed by the diagonal. Uh-oh, here it goes. CF. Okay, so let me draw it in a different color here. It's the diagonal is formed here, going all the way up to here. It's inside, and then CH. Oh boy. The only thing is, if I were to make this here, I get myself a right triangle. True, true. But I'm inside, so this is 5, and that's 5. Okay, hold on. Oh, hold on. These are, if it's a square, this is a 45, 45, 90 triangle. Is that right? And we are so cool like that because if we know the two sides of 45, 90 is 5, what is the hypotenuse? 5 root 2. Is that right? So you kind of think of it like you're thinking flat across the edge there. All right, and we want to know, find the sine and cosine. So I need to know sine and cosine. And I'm going to write theta. We good? And I'm going to put theta over here because I don't even know what that angle is. Okay, but everybody okay there? That's just the bottom, right? That's just the bottom piece there. If we drew it out just by looking at it, that's what usually we do. So the bottom pieces are G, C, D, H, like that right here, right? If I'm looking at the bottom, I know that's 5, I know that's 5. And then this diagonal across here, laying flat, is 5 root 2. And that's because it's a 45, 45, 90 triangle. Ta-da! Okay, next is, now we got this diagonal here. So this diagonal is coming across here. If that's 5, and that's 5 root 2, can I know what the diagonal is coming across, the inside? So this is, you got to kind of visualize it, and a lot of part of trig is visualizing it. So this bottom from C to H is 5 root 2. This is 5 from F to G, and then that is right here. So Pythagorean theorem it is. Boom, 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 squared plus 5 squared would get me CF squared. So 2550, is that right? That's 25. Got myself a 75 over here. Running out of room here. Anybody with a square root of 75? This is interesting too. So it'd be, yeah, 25 times 5, is that right? No, 25 times 3, right? So it would be 5 root 3 is CF. That is kind of unusual. Do you guys think that's kind of cool? So then you have 5. Oh, hold on real quick here. This is the crazy stuff. You guys ready for this? Isn't technically this is 5 root 1? Oh, awesome. So this is 5 root 1 technically, right? So when you form a diagonal off of a 45, 45, 90 triangle, you get 5 root 2, right? If you keep doing that, it is like the shell, right? It keeps conforming. So then if I made this into a supercube in 4th dimensional space, the diagonal of a supercube in 4th dimensional space would be 5 root 4. Are we good? Yeah. Should we? I gotta check out this. Supercube. Gotta do the supercube sometime. All right. I gotta write that. So supercube for next time. Supercube. All right. So what is the sign of this here? Sign is opposite over hypotenuse. So I think we're good here, right? Opposite is 5. Hypotenuse is 5 root 3. Everybody okay with the 1 over root 3 for the final answer? And then the cosine. Cosine is adjacent. Okay, that's adjacent. So 5 root 2 over 5 root 3. Oh, that's a fun one. This is going to be a root 2 over root 3. All right, do we keep it like that? Yes, you may. We're good. The interesting thing is, in mathematics, you would never have a fraction inside a square root. We're good. You can split them off. That's cool, but not inside a square root. Okay, that is 61. Are we good there? Oh. It'll just be 2/3. Yeah. Oh, gotcha. Okay, so acceptable answers for root 2 over root 3. So this is acceptable. This is just fine. It's just the rational, the denominator is not rationalized. That's perfect. We're good? That's one answer. The other answer is to rationalize your denominator. So multiply by root 3, multiply by root 3. This is the way you normally would see it in algebra. Is that right? Right there. That's a nice answer in algebra. All right. What would not be good? This would not be good if you have a fraction that's still inside a square root. We don't consider that simplified. So if you have a fraction inside, you have to do something about it. Either split it and then eventually rationalize your denominator. That's fine, but that's a no-no. This is happy face. And that's a happy face. Well, then let's see. If this one's happy face and happy face, this would be sad face. Okay, we good there. 63. We can answer this one already because it is that easy. 63, 2.1, 63. It says if each of the sides, oh, just like same one. Suppose that the cube of in figure 8 is, oh, no way, it's x inches. Whoa, hold on. The power, I think it's the power. No, it's not. Okay. Now we have this. A, B, C, D. Offset them diagonally, and then connect the corners. All right, E, F, G, H. Okay. Okay, got it done. And we got ourselves, oh, if this is X now, a variable, that's it. So you got to do 61 before you do 63 or else it's really confusing, right? So then let me change colors. So we just look back to 61. You got to look back to 61. If that's X, and then if we cut across here, this would be X root 2, every degree there. And because we would just did, if I take a diagonal from here all the way to F, I know that is X root 3. Cool, everybody okay there? As we look to number 61 here. This is going to be opposite over hypotenuse again. And let's see what happens. Opposite is X over hypotenuse X root 2, and the X's all be gone. Is that right? That is so crazy. X over 3, even better. Thank you, Gabe. Yes, please correct me if I do something wrong. I like get into math so much, I forget about numbers. I had a math professor. He actually, during class time, he was thinking about something. This is like upper division math and stuff, right? So he's like, oh, I wonder. And he's like, hold on, guys. And he goes, and he just starts doing for the next half an hour, right? Just piling the board up, right? And so it was like, I think I just did something. And then next month, yep, he gets it published. It was new stuff that, again, was was something that was in the field, right? So Fresno State. And he was like, "This is so cool." So like that's kind of cool to see that excitement, energy of the professors and stuff like that. So, but um, he did. I think he did during his tenure there. He actually discovered two things new that was never in any. It was never a problem. It was never anything in any textbook or anything. Yeah. But tell him to multiply 4 times 5. No clue. The guy could not add, subtract, multiply, or divide. It was all theoretical in his brain, and he's been studying theory so long. He hasn't touched numbers in so long that he like does not do 4 times 5. So so what we had to do is we had to help him out all the time with like what is because he is he taught calculus as well. It was even worse in calculus because calculus has numbers, right? So he's like, I don't know, guys. I'm not sure how I'm going to teach this class. So we had to help him with the multiplication. But to do high theory, high cerebral mathematics, he's totally there. I'm not sure how he would function practically, though, right? Like, what happens when he gets home? You know, it's like, does he have any concept of budget or something? You know, like what? Anyways, adjacent is this guy over this guy. True, true. And what happens? What does this tell us, guys? They're the same as 61, right? So the ratios, no matter how giant this cube is going to be, right? The sine and cosine, at least the sine and cosine, maybe the others, I'm not sure. At least the sine and cosine ratios are exactly the same. They will never change. We're good. The ratios are the same. It's kind of like, you know, when you take the end of a picture, right, and you on PowerPoint, right? You extend the picture out, you make it bigger, smaller, right? The ratios stay the same. Exactly like that, right? Okay, so let's keep on going. 2.1 is done, is that right? Okay, 2.2 it is. 2.2, number 55. All right, this one you may need your calculators here. So theta is between 0 and 90 degrees. I need to know round to the nearest tenth of a degree when this is true. So remember, we're going backwards, right? We have the ratio. The ratio is already given. 0.97. Is it 770? Is that right? All right, so I'm going to show you kind of what is happening. Let's do this real quick here. Just for you guys to kind of understand here, because this is a new concept here. Did you guys remember? Oh, no, it's okay. We'll just go with it here. So I have to get rid of cosine, right? And remember in algebra, we have to do the same thing to both sides or else it doesn't work. Is that right? So what we technically do is this. I'm trying to undo it. So I'm going to take the cosine inverse. That's what I'm doing here. And then I'm going to do the same thing here. Are you okay with that concept? That's technically what I'm doing. I'm doing the same thing to both sides. Good? Now, because we're between 0 and 90 degrees, it allows me to do this. And we'll talk about it at the end of chapter 4 a lot more. We'll totally get into. But that's technically what's happening here, math-wise. We're taking the inverse of both sides. Make sure your calculator is in degree mode. And anybody help me out here? Punch this in, or do I need to punch it in? Should I punch it in? Perfect. Okay. Well, yeah, since I'm doing homework, I might as well just show it to you, right? Yeah. Thank you. Calculator, come forth. Boom. Love it. That's cool. Okay, so real quick here, I guess we should check this out here. That's why I checked if anybody had degrees. So mine starts off in radian mode really quick here. We'll talk about radians later on, but I have to go and I got to change it to degrees. And all you do is you use your arrow keys, click on it, make sure that's the highlighted one. The cool part of the calculator is the fact that you have, look at this, this is called function, which was x and y. Is we good? Then you have something called parametric form. That's cool. That involves x, y, and t. Then there's called polar form, which we'll discuss all the way at the end. That actually involves theta and r. And then this one is kind of like playing Battleship. It's sequential, so it's like things are moving at the same time. We good? And you see if they actually collide or not. like planets just revolving and stuff. Like, well, did they collide? Nope, it didn't collide. But we're in function mode right now. Zoop. Okay, so I'm going to go cosine inverse. So second function inverse is 0.9. Now, before you do this, just real quick here, you guys tell me, is it more closer to 90 degrees or is it more closer to 0 degrees? So if you go back over here, this will be a cool thing to talk about. So remember how this guy is 1, 0, and this guy is 0, 1. True, true? And so cosine theta is, or cosine of 0, right? I should say this, right? Cosine of 0 degrees would be 1 over 1. Everybody agreed there? So as cosine is close to 1, this is your degree value. We good? So then let's go to the next one here. Cosine of 90 degrees is, everybody okay with 0 over 1? Good. So if cosine a very small number, 0.0342, we good? I bet you it's close to 9 degrees. All right, so this one is 0.977. That's barely off. So I should expect something in here, right? Real quick here, right there. So let's do that before we do it. And answer is, yeah, about 12 degrees. We're good. A lot closer to 0. Round to the nearest tenth, about 12.3 is good. Correct, yeah, in nearest tenth of a degree. Cool. Oh yeah, absolutely, yeah. So if you're gonna do it by calculator, you might as well just do it by calculator. Good. So, all right, and then we got next one. Not that one. That's not what I wanted. I wanted this. Okay, 65, 2.2, 65. All right, I got. Is this cotangent? Cotangent. What? We did not do those in the notes. 0.68. What? I think it's 7.5. You guys check with me. 7.3. 7.3 it is. Okay. Okay. Class, let's do this one here. Oh wow. Anybody tried on homework and got it? Raise your hand if you got it off the homework. Like, yeah, I got it. Sweet. Okay.
I don't know what I did.
Okay, let's go with it here. So here's officially what we should do. Cotangent is not found on the calculator. No. So here it is. What we're going to do. Cotangent is the same thing as 1 over tangent. That's cool. And you guys can see some chemistry, I think, in here. So if this is the reciprocal, then this better be the reciprocal too. Is that right? 6, 8, 7, 3. So that's true. Is that true? Oh, no, it's not true. Hold on. It's not true. Nope. Brain freeze. Long way here. So that's true. Is that true? Yeah. And this is still true. Everybody agree there? Okay. So is this true? Oh, interesting. Okay, let's go back to algebra. So if I have 3/4, which is equal to, I don't know, 27/36. Is that right? If that's true, is this true? Can I just take reciprocal? As long as I take reciprocal of both sides, is that right? What is the reciprocal of 1 over tangent? Tangent. Awesome. What is the reciprocal of blah, blah, blah over 1? 1 over blah, blah, blah. All right. Yep. Cool. So we're going to punch into calculators that. Now we can do this here. Theta is equal to, oh, got it. So all we had to do was to take the reciprocal of the value itself. We good? So in order to get the trig function, take the reciprocal of the value or of the ratio. Sweet. Second function, tangent. 1 divided by 0.6873, I believe. And the answer is perfect. I'll go with that. 55.5. Whole bunch of fives with a degree symbol next to them. Jump. All right, and 91. All right, 2.2, number 91. And I guess this has been a homework day for today, right? Oh, go backwards here. I got to fill out a table. I need to know the cotangent. Oh boy, here we go. Cotangent of x of, is it cotangent, right? What? Complete to the following, round all answers to the nearest tenth. Okay. Let me see what we're supposed to do here. Is it just by calculator? I guess it's just by calculator. Yeah. I need to know 3 degrees. So I need to know cotangent of 3 degrees. And are we just doing it by calculator? Yeah, because there's no other. Boom. Okay, so cotangent of 3 degrees. Bummer. I can't do it directly, right? So I'm going to have to do careful on this one. Yeah, so notice that 3 degrees is going to go down here. We're going to take the reciprocal afterwards. We good? So it's going to be 1 divided by tangent of 3 degrees. And we have some cats in the house. 19, right? 19.1? Everybody okay with that one, right? Oh, not degrees. That's the ratio now. That is crazy. Those are some big ratios, right? Notice that sine and cosine, they can't be above 1, right? But tangent, and cotangent is at 19 right now. That's cool. Okay. So, do we keep on going? Are we good there? 2.5? I think everybody is okay with that one now. Let me just do one more just for completion's sake here. So I got cotangent of 2.5 degrees. That's going to be the reciprocal of tangent of 2.5. And we keep on doing it. And I'm not sure why they want to do this so many times. Divided by tangent 2.5. Okay, whoever asked for that one, are you guys okay now with that? I guess they want you to just sort of see this here. 22 point, these numbers are just getting bigger. I'm at 22.9, we good? So if I go over here, okay, I guess we should. So this is just thinking through here. I got that one. So these numbers start at 19, right? Now we're 22. I wonder if I skip across tangent of 0.5. 1 divided by tangent 0.5. Whoa. 114.6. Now that's a little bit away from 1. Not degree symbol, just the value. Okay, so then this guy, cotangent of 0 is going to be 1 over. Thank you guys so much. You know what? I've been doing 90 all this time, but no one told me that I've been doing 90. But it's fun to do 90. Just wish I was doing 91. Oh, so. Okay. Oh, I thought I had the wrong so, no. I see a few people like, what? Sorry, this is 90A. But let's finish it off now. So what happens here? So I go from 19 to 22 to 114.6. Now I go to this, and then we'll actually do the true 91 here. Sorry, my mistake here. I make mistakes sometimes. This is one of those. Okay, if I do this, guys, real quick here, look at this. What's going to happen here? Answer is, can't divide by 0, because tangent of 0 is this right here. So my question to you guys is, what is this number? This is undefined, right? But as I get closer and closer, I start at 19, now 22, now I'm at here. Oh, cool one. You guys do this one here? 1 over tangent of, let's do, let's see, degrees, right? Getting closer to this one. How about this? 0.0005. What's tangent of 0.0005? Dang, okay, 11,000. 114,591. Thank you. Okay, what's happening to these numbers? So cotangent, as the angle gets closer and closer to 0, right? The The cotangent function goes where? Goes to where? Infinity. Absolutely. It's getting bigger and bigger and bigger. Class, we did not have time for 91, but do you guys remember making sundials in, is it algebra 2 or geometry? Which one? You didn't. Oh, that's right. That's right. Yeah. Uh-huh. Let's see. Let me see if I can do it real quick here. We're good with this one? It says sundials. The Moorish sundial designed in the shadow of the gnome. Oh, that's funny. That the sun, the shadow will sweep down an angle towards the cast, labeled theta. And it says this. No, it's going to be too late. It's going to be a little too long. I'm going to stop here.